So we'll start. So let me just go to one slide. For example, yeah. So if you just observe at the topic, I would have given motion magnification 2 to 2.5 hertz. So that is something called as the band pass filter, which I am fixing. You understand? So that means for a particular structure, if I want to excite a particular mode or a particular frequency that I want to extract, I should know that range. So then only this method is going to give us a good results. You understand? So I know that the lateral mode is something like in between 2 and 2.5 hertz. Because of conducting some simulation, we try to understand that. Then I am trying to fixing that as like 2 to 2.5 hertz. So I could able to get the clear cut magnified things, and I am extracting the particular excited mode between that range. Suppose if I don't know that, suppose if I am not aware what will be the range of that frequency, what will be the exact value. If I am not aware of it, then what you will do, you will try to fix, or you will try to have a trial run. Okay, you will try to fix between like 1 to 5, or you have like many number of trial runs to do or extract it. So that is something like a disadvantage of this method. So you need to know the frequency value beforehand while you are going to run this process. So to overcome this, so we have something called as unsupervised learning algorithm. Okay, so this was like something like where no need to know the value. Okay, so you given the like fulfilled measurement video, you just try to process it, and like automatically you're going to extract the value. Okay, so that's the advantage over this research work. Okay, so I think like this research work was conducted by when he was BTech student Subhajit. So he did this work. Now he is doing his PhD here. So this is like very simple, same, more or less the process is same, but I'm just trying to replace few methods from the previous methodology, where we are going to use this PCA, principal component analysis. So then we are going to play with the same motion matrix, and we are going to extract the parameters. So that's the idea. Okay, so you have an input video, you have image filtering, multiscale decomposition, phase extraction. Up to that almost same. From there you try to extract that phase matrix, which is going to have the motion of that particular structure or a system. We are going to play with that motion matrix, where you are going to apply the principal component analysis and do the extract the components from there, principal components. Then you are trying to implement the AMD algorithm, which is like analytical mode decomposition, because principal component analysis is going to give you the components which is having a mixed modes. Okay, so from that mixed mode I need to decompose which is that exact mode that is excited. Okay, so where I'm going to use this analytical mode decomposition. Okay, AMD technique. Then again I'm just going to follow the same pattern, random decrement method, to get the free decay signal and do the model parameter analysis. Okay, so that's the idea behind it. So the same bridge which I showed you in the first slide, so we have done the analysis for this London Millennium Bridge. Okay, so this was opened in 2000. It's like a steel suspension bridge. Okay, so due to the synchronization of the lateral excitement, okay, by the overcrowding pedestrians, so there was a large sideway movement. Okay, so then they tried to avoid that using a lot of damping systems. Okay, so from this video, okay, so I think I have run this video earlier. I have just like cut the few part of that video where to just to avoid the noise and etc., and where I could able to clearly see the vibration. From here we are trying to extract the things. Okay, so this is something like a poor resolution. 480 pixels is something like a poor resolution comparing to today's cam that we have in our smartphones. Okay, so even from that low resolution, how we could able to extract. Okay, that's the point here. So this is the amplitude part and the phase part. We are trying to play with the phase part, and we have done some eigenvalue decomposition just to understand how many modes that I could able to extract. So from here happily we could able to extract 1 or 2. Okay, so bridge swaying occurs as the pedestrian's walking frequency and the bridge natural frequency range is matching well. That's the reason it is like having that vibration. If exactly it is going to match, resonance will happen, where you will have a huge vibration, which is not good. Okay, so there are like 3 frequencies that we can extract from here. So these are all the 3 frequencies that we could able to extract from the principal component analysis. Then after implementing the analytical mode decomposition. Okay, so where you could able to easily have a comparison, okay, with the previous experimental studies that has been conducted in way back 20 years. So where the values are like almost similar, like less than 1% error, which is like quite good value that we have obtained. Okay, so of course, like nowadays, like we have this advanced UAVs. Okay, so I think we have discussed a lot about these drones. I'm not going to discuss anything about this. So let me just go to the, yeah, so this is the bridge. I just actually we planned site visit to, I mean not site visit, I should tell, the inspection of this bridge. That's what that's the plan, but then we changed to this same like LHC center. Okay, so this is something like the road over bridge. Okay, so this is something like the nearby village name, Kudupur and Tarabai road over bridge. Okay, so this is the bridge which is connecting the village. Okay, so this bridge is belonging to IIT Bhubaneswar, so we can do some experiments without any further permissions. Okay, so let me just play this. So I think you played with one drone, right? That small one, that mini Pro DJ. So that's the drone that we use to do the inspection. So quite good resolution cam we have in that. Okay, so still video that we could able to capture without any much disturbance and etc. Okay, so where we could able to, like, there are a lot of vegetations which is disturbing, but still like we could able to get good thing. Let me just play. This is almost like 15 years old bridge. It is almost deteriorating, so you could able to see a lot of spalling. Some few places there are like corrosion is there. Okay, cracks of course, so they are not maintaining it. So yeah, so this is something in the, so I think you understand what is a gimbal angle, right? So in the drone you could able to change the focus of it. So that's what we did here. So where we're trying to understand, you just see a lot of like extra rebars are like coming out, no like proper finishing has been done. So this is something like inaccessible area where we could able to under the bridge I'm talking about. Okay, so these are the things that we did. So I thought at least I will show the video that we have collected. Okay, so you could, so what are the damages that you could able to identify from this? Can you tell? Quickly observe something. Yes, so there are some extra bars which is not even cut. It has to be, yeah, cut, and there are a lot of cracks, too much. So in between each casting of that concrete, there you could able to see that brown color, which is because of that corroded bars inside. Okay, so that is like coming out. Maybe during rainy season, like you could able to see there are some leakages. Okay. Let me just play this video. Maybe you can observe more damage is there. Proper finishing is not done. No coating is given. Okay. Where? This side? This side there is spalling. Here also there is a spalling of concrete. You're right. This is right. These are some extra bars that is coming out which need to be cut. There is no proper finishing. See here you could able to see some spalling of concrete. This side. This here also. So this is that cross beam. So where you could able to see this spot. Okay. So these locations. Maybe if you could able to maintain, have some coating over it, it will be like looking good, but we are not doing it. We should do that. So these are all like damaged locations. Yeah, but quite new bridge comparatively. It's like almost 15 years. So fine. I think this is my last slide, I guess. Oh, we have more. Huh? Drone. Yeah, of course we are planning to analyze. It's under process. That's the reason. Like I got able to show that. So what we are planning is like we have this video, right? We are going to again decompose this video into number of like frames. We will get a lot of images. So we are going to run some deep learning models to categorize or classify the type of damages. Yes, yes. Oh, no, this is not vibration measurement. No. Yeah, this is not for vibration measurement. So there are two things we planned. One is for the 3D reconstruction of the bridge using photogrammetry. That's one part of the work. And another one is like semantic segmentation, like normal deep learning techniques to use to classify the damages. So that's the idea. So I'm just showing this drone video just to, because I felt bad that we didn't go to that site. So just I'm showing that video. Yeah, certain distance, if it is not like moving, I think with this drone it is like quite simple to do that. We can do that, yes, because you could able to see the so you cannot observe any vibration of drone. So it's really good. So because yes, exactly, yes. So it's really good. Fine. So of course the whole the agenda of this course is something integrating computer vision with the AI, I think. So that's the point here. So anyway, I'm not repeating these things. Yeah, so this one thing I just saw in some papers, which is like saying everything. This one slide is explaining everything whatever we are discussing throughout this course. Okay, so SHM at local level, crack delamination, where you could able to do in 1 year in terms of intervals of 3 years or 5 years. Okay, so robotic techniques are UAV based. Okay, scanning, all those things can be done. If it is on a global level, like we were explaining about this camera based non-contact, that we can do. At the end we are trying to like combine these two things, where this nowadays the digital twin is coming into play, where you try to model and understand in the real time how your structure is performing. Okay, so then you could able to have a maintenance scheme or the repair works that can be done. So this is one slide which is explaining everything that we are trying to discuss. So our focus is something like where we do this the last stage. Okay, yeah, I think I'm done with here. Thank you. If you have any questions, we'll take up. So